Hello everyone. Today let's solve the problem number 210, course schedule 2. So we have already solved course schedule 1. So here let me tell you, if you have followed this one, the previous problem, course schedule 1, just listen to this. So this is exactly same as course schedule 1. There is only one change. Instead of uh, we had to find, or we had to return this one boolean value true or false if we had found this one, the number of courses, right? So the number, if we had find number of courses, we had to return boolean value true or false. In this problem, so we will be instead of the boolean value, we have to return the ordering of the courses that we should take to finish all the courses. That is the only difference. The return value differs, all the other steps or the code remains same, right? So we just have to return the order of the courses that we need, that we should take to complete all the courses, right? So let's discuss this one from starting. So just ignore that one if you have not followed the course schedule 1, right? So let's discuss this problem first. We have number of courses, right? So we have number of courses here labeled from 0 to n minus 1. Again, I'm telling, we have courses, number of courses labeled from 0 to n minus 1, or the number of courses minus 1. Number of courses I'll just consider here nc minus 1, nothing but number of courses minus 1. Some courses have prerequisites, meaning we must take the specific courses before another. So here you can clearly see we have some courses have the prerequisites, meaning that we have to take a specific course before another. In this case, we have to take the course this one, course 0 before completing course 1. So that's what they are saying in the question, right? So we need to determine an order in which we can complete all the courses. So again, I said this one in the beginning itself, we need to determine an order in which we can complete all the courses. If multiple orders exist, then we can return any valid order they have given. There is no constraint that we have to follow particular order itself. We can go with any valid order. We need to determine an order in which we can complete all the courses. So if multiple order exists, so then return any valid order. If it is impossible to complete all the courses, then we can return an empty array, right? I hope this is completely clear, right? Then let's start with the approach. So initially here you can clearly see, let's discuss the examples, then let's discuss the approach, right? So example, they have given number of courses 2, prerequisites 1, 0, and output they have given here as 0, 1. Why? Because there are total of 2 courses to take here, they have mentioned here, and to take course 1 we have to take course 0, this one prerequisites. So while explaining the question I said, so there is one condition of the requirement that here, if their prerequisites exist, so we have to complete course 1 first, 0 first before taking the course 1 here. So to take course 1, we should have finished course 0. So the correct course order is 0, 1. I hope this is clear. So if we go to the example 2, same thing, number of courses 4 they have given, prerequisites 1, 0, 2, 0, 3, 1, and 3, 2, right? So this one, when we discuss the approach, you'll come to know. So if we represent this one in the form of, we can visualize this one in the form of graph, basically directed graph. Then we solve, if we then try solving the problem, it will be very easy to understand. So I assure it. So output they have given here as 0 to 1, 3, because so explanation they have given clearly here. There are total of 4 courses to take, number of courses here. To take course 3, we should have completed both 1 and 2, right? 1, this one 1 and 2 to complete 3. That's what they have given. Both courses 1 and 2 should be taken after we have finished course 0. After finishing 0, we have to take 1 and 2. So after completing 1 and 2, we have to take a course 3. So that's what. So one correct order is 0, 1, 2, 3. Yeah, 0, 1, 2, 3 we can go. That is right. So another correcting order is 0, 2, 1, 3. We can display any order. any one solution, right? So here it can be of any order they have given. Either we can display this one written 0, 1, 2, 3 or 0, 2, 1, 3. Order doesn't matter. They have that's what they have mentioned in the question. So here let's come to example 3. Number of courses 1 they have given, prerequisites nothing. So we can just directly return 0 here. We have to display 0, right? So I hope the question is completely clear. We will be following exactly same steps. The code will be exactly same except the return value, right? We have to initialize the order in the step 3 compare it comparatively, and then in the return value we are just changing the return value accordingly with the question, right? So let's discuss the approach first, followed by edge cases step by step, and then finally write the code, right? And discuss the complexities of the code that we have written. Initially, let's discuss the approach. So we'll discuss the approach step by step. So I have just considered the same this one example that they have given in the question. They have mentioned in the question. The first example that they have mentioned in the question, number of courses 2 and prerequisites 1, 0, and output we need to get here is 0, 1. So we will be going with the topological sorting using the cons algorithm. So topological sorting with BFS, right? So this one, just remember this one. We are just going with the topological sorting using the cons algorithm, right? Or topological sorting with BFS. Let's start with the approach. So first what we will do, number of courses here is 2 and prerequisites here is 1, 0. This one I'm speaking of, right? So courses we can write in this form. So courses will be 0, 1. Why it is 0, 1 here? Because prerequisite they have given 1, 0. This is prerequisites. Course is 0, 1 because we have to complete course 0 before taking the course 1, right? So that is the reason we can mention the courses as 0, 1 here. So prerequisites is 1, 0. This is fine. This we know. Let's come to step 1 here. In step 1, what we will be doing here? So as usual, we'll first build a graph in degree array. So let's build graph and in degree array. So here for building the graph, so here as I have said, in the prerequisite they have given here, to complete the course 1, initially we have to take the course 0. So this one we can visualize in this way. Let's consider the directed graph here, 0 to 1. To complete course 1, we need to complete course 0 first, right? So this is represented in this way, right? Course 0 leads to 1. So let's consider the in degree, right? In degree means, so 1 has an incoming edge here. You can clearly see this arrow mark, right? 1 has an incoming edge 1. 1 has an incoming edge. So in degree of 1 will be 1 itself, and in degree of 0 we don't have an incoming edge to 0, right? In degree of 0 remains 0 itself. In degree of 1 will be 1 in this case. I hope this is clear, right? So this is for the in degree. This one adjacency list. Adjacency nothing but this can be visualized in the form of 0 to 1 because prerequisites they have given 1, 0, where we have to complete 0 before taking the course 1. So this can be represented in this form. This will be adjacency list and this will be in degree. In degree of 0 remains 0 and 1 will be 1 in this case. This will be the step 1, right? Let's hop into step 2, or let's discuss step 2 here. Step 2, we have to find all the courses with 0 in degree here. Find all courses with 0 in degree. So the people who have followed the previous question or the course schedule 1, so this remains same. So just ignore this one and directly you can just hop into the step 4. So only the return value changes, as I have said here. So people who have not followed, you can just follow from the scratch beginning. So the step 2 here, we have to find the courses with 0 in degree. When I say courses with 0 in degree, so here this is the only one which is having the 0 in degree. So the course with 0 is having the in degree 0. So we will start with it. Course with 0 is having the in degree 0. So we will be starting with this one, right? Let's move on with the step 3. This is it for the step 2. Let's move on with the step 3. In the step 3, what we will do, we have to process the queue. We have to process the queue here. When I say process the queue, first we have to take the course 0, because we are considering initially, we have found all the courses with 0 in degree initially, right? So I said in the step 3, we will be starting with this one, 0 itself. So we will take course 0 first, then we will pop this one, and we will reduce the in degree. What we will do, we will reduce the in degree of 1. Nothing but 1 becomes 0 here. So same step. We will consider 0 first. We will pop 0. We will consider the in degree of 1, and we'll be reducing the in degree of 1. Nothing but here, this is important. Reduce in degree of 1. Nothing but 1 to 0. Next step, we have 1 here. We have already popped 0. Next step, we have reduced the in degree of 1 to 0. Now we will consider 1. We will add 1 to queue here. We will add 1 to queue here. So will not pop. So this one, just ignore this one. We are not popping this one. Let's consider 0 here. That's it. So we'll consider 0. We will add to the queue. Next step is we will reduce the in degree of 1 to 0, and we will add 1 to queue. This is step 1 and this is step 2. So now we have the this one, valid order, nothing but 0 to 1. 0 first and 1 is the second step, right? So that is what we have to return. So step 4 is get final order. Sorry, get final order, nothing but order will be in this case 0, 1, right? So this will be valid order basically. So this is what we need to get in the output. That's what 0 first and 1. So first here in the step 3, again I'm telling, we have to consider 0. Accordingly with the step 2, we are considering 0 first, and then we are reducing the in degree of the 1 to 0. Then we are adding 1 to queue. So the order will be 0, 1, right? So I hope this is completely clear. So this is the approach that we'll be going with. Next, let's start discussing the edge cases one by one. I hope the approach is completely clear. So first edge case we are going with here is no prerequisites. No prerequisites means independent courses, right? So here input will be number of courses. I'll just consider here 3. Prerequisites, nothing. No prerequisites means by independent courses we are considering. Output here will be 1, 2, 3. Sorry, 0 we have to consider, right? Sorry, in this case. So just give me a second here. So in this case, output will be 0, 1 and 2, right? 0, 1, 2, because we can go with any order, man. If you have got 1, 2, 0, it doesn't matter. Order doesn't matter. You can we have to just display, or we have to just return the valid order. That's it. Order of the elements doesn't matter. So order of the courses doesn't matter. So any order is valid here. So this is for the condition no prerequisites, right? You can just visualize in the same way, or you can just try it out in the same way that I had shown for the example 1. You'll get the output, same output here, right? So I hope this is clear. Next edge case, or the second edge case that we'll be going with here is single course. When I say single course, number of courses I'll just consider 1 here. Prerequisites I'll just consider P here, P. Again, this one empty I'll consider. Output will be 0 in this case, right? We have only 1 course, so the output will be, order will be 0 here in this case. So third one, let's consider here cycle exists. Cycle exists here. So what we'll do here, number of courses, let's consider 2 here. Prerequisites, let's consider here 0, 1 and 1, 0 here in this case, right? So output will be empty array. Why? Because cycle is detected, no valid order will be present. So output will be this one, empty array. This is for the condition cycle exists. So let's move on with the last edge case, multiple valid orderings. So here multiple valid orderings. This is fine. So input, let me give here. Input, let me consider number of courses 4. Let me consider here multiple valid orderings, right? So prerequisites, let me consider here 1, 0, 2, 0, 3, 1, and finally 3, 2. This is fine. So output will be here in this case 0, 1, 2, 3 or 0, 2, 1, 3. The same thing that they have mentioned in the question. Second example 0, 2, 1, 3. So this is valid, right? So this is for the condition multiple valid orderings. This one I don't have to explain. I have already explained this one, right? So I hope all the edge cases are clear here. The first one that we considered was for the no prerequisites condition, no prerequisite. Second one was for single course. Third one was for cycle exists, and fourth one was for the multiple valid orderings. I hope all the edge cases are clear. Now let's start writing the code. So let's start writing the code. Initially, as usual, let's create the adjacency list and in degree array. So that's what we saw in the approach, right? So I'll just give here let graph equals array dot from. So here what I'll do, I'll just give your length num courses. So number of courses that will be. This is fine. So this is fine. So in degree, let me just give here. Let me consider, or just give me a second here. Let me give this one in next line so that this looks good actually. So this will be new array. Let me consider unsigned integer 16-bit array. So I'll just give you a new uint 16 array. This one, let's pass the number of courses, num courses here, right? So this is fine. So we are just creating the adjacency list and in degree array here. Let's move on to the next step. We have to fill the adjacency list and in degree array here, right? Nothing but let's go with the for loop. Same thing. Course and pre of prerequisites. So let me copy the same thing. So this is fine. After this step, so we have to point the prerequisite this one to the course, right? So how can we do that? Graph of pre push. This one we are pushing this one. So what we have to push? Course, right? So this is fine. Next we have to increase in degree of the course. So I'll just consider here in degree course, right? We are just incrementing the in degree of the course. So I hope this is clear. So this is for the step we are just filling the adjacency list and the in degree array initially. So let's move on to the next step, or the step 3. So we have to find the courses with 0 in degree. If you remember, we have to find all the courses 0 with in degree. In our case, 0 was the only thing which was having the in degree 0, right? So we have to just articulate the same thing in the form of code. I'll just give here let q equals in degree dot reduce. So this one, let me consider q v I. This is fair. So here let me give v q dot push iterated value of the queue. This one, we are just pushing the I, right? So this is fine. We have to consider queue as well. So this is completely fine. So the next step is we are just reducing, right? So initially, let's keep the empty array here. So the only thing I have said, which is different from the previous problem, course schedule, this one was we have to return this one. So here we have to return the order of courses that we should take to finish all the courses. For that one, we should have order, right? So I'll just consider order and initialize this one to the empty array initially. So fourth step, this is very important. We have to process all the nodes in topological order. Let's quickly write this. While queue of the length of the queue, sorry. Then we have to take the course with no prerequisites. So initially, let me initialize the course to queue. So this is fine. The next step is let's add to the result order. So for adding, I'll just consider push here, push of course. This is fine. The next step is let's reduce in degree for the dependent courses. So for loop, let next or graph this one within the course. So this is fine. So let's quickly write simple if condition here. If in degree becomes 0, then we have to add that one to the queue, right? If in degree becomes 0, then we are adding that one to the queue. Next step, this one. First we considered 0, which were having all the in degrees as 0. First that we considered, right? In this example, it was 0. Next step, if the in degree becomes 0, because we were reducing, we had 0 and 1. 0 was having in degree 0. So first that we considered. And the second step was we had 1. We reduced the in degree of 1 from 1 to 0. And then we added that 1 to the queue, right? So here, if in degree becomes 0, then we will add that one to the queue. That's what we are articulating that one in the form of code. Simple if condition here. If decrement in degree, next here, this one is fine. If this is equal to 0, we are comparing, right? Then we have to add that one to the queue. For adding, I'll just make use of the push here. This is fine. Next. So I hope this is clear, right? So the final step, we know this one. If all the courses are processed, then we just have to return the order. Otherwise, if we don't have any this one, we don't have the particular order, or if we don't have anything within the array, so then we have to return the empty array in that case. So return length of the order here equals number of courses. So this one, length of the order, if it is equal to the number of courses, then what we will do, we will display the order. So only this return value actually differs. So this is one thing. So previously we were going, it was completely based on the number of courses, right? So we were just checking number of courses. So whether the number of courses, yeah, previously for the course schedule 1, if the number of courses was equal to the number of steps in the step 3. So step 3, what we did, we added this one elements to the queue, right? There were 2 steps basically. So the number of courses that we took were equivalent to the number of courses that they had given in the input. Then we were returning the Boolean value. Here, if the length of the order is equivalent to the number of courses that they have given in the input, then we will display order. Then we will return order. Else, we will go with the empty array. Nothing but if all the courses are processed, we are returning order. Otherwise, we will return empty array. I hope this is clear. This is the only difference between course schedule 1 and course schedule 2 question, right? So I hope this is completely clear. Let me format this one once and return the, run the button. Sorry. Yeah, let me hit the run button. Sorry. So So you can clearly see here the sample test cases are getting passed here. So let me hit the submit button. So here you can clearly see all the test cases are getting passed here, right? So the code works absolutely correct in this case. So let's quickly discuss the time and space complexities of the code that we have written, right? So the approach that we went with here is topological sorting with BFS using Khan's algorithm, right? So the time complexity would be here. Overall time complexity would be big O of V plus E here. V is nothing but vertices, E is nothing but the edges. So here we are processing all vertices and edges. So overall time complexity would be big O of V plus E. So then what will be the space complexity here? Overall space complexity would be big O of V plus E as well. So why it is big O of V plus E here? Because we are considering adjacency list plus in degree array in the memory here. This one you can clearly see. Adjacency list and in degree array, right? So the overall space complexity would be here because of V plus E. So the time complexity and the space complexity for this particular code will be big of V plus E. I hope the solution that we have written is completely clear. For now, this is it. Thanks for watching, guys.